Okay, we are dividing with exponents here in this activity. Remember our rule with dividing? You have a to the m divided by a to the n. So if you have the same base, you're simply just going to subtract the exponents, and that's going to be the process. That's going to be our shortcut. So let's start with question 1 here. First thing that I'm going to do is I'm going to draw a fraction bar. Now let's look, 10 to the 4th over 10 to the 6th. The rule said you are supposed to just simply subtract the exponents when you have the same base. Notice we have the same base of 10. So we're going to do 4 minus 6. Now whatever answer we get here, we're going to put that in the top part of the fraction bar. Now be careful, because 4 minus 6 is not 2. If you take your calculator and you do 4 minus 6, 4 minus 6 is not 2, it's actually negative 2. So you have 10 to the negative 2 power. So if you go back to your rules with negative exponents, the rule said change the sign and cross the line. Well, if I change the sign from negative, it would have to be positive. And in order to cross the line, it would jump down here. So actually, that would look like this. And our answer would be 1 over 10 to the 2nd power. So if you have a negative exponent, change the sign and cross the line. Kind of confusing for question 1. Let's look at question 2 to see if we can find something that might be a little simpler here. Let's look at question 2 here. So let's start by drawing our fraction bar here. Okay, start with the numbers 12 over 3. 12 over 3 is a whole value of 4. If you get a whole number, it goes on the top. A to the 1st divided by a to the 1st. Well, if you do a to the 1st over a to the 1st, remember our rules, just subtract the exponents and you get a to the 0. What is anything to the 0 power? It is a value of 1. And if I took 4 and multiplied it times 1, I would be left with an answer of 4. Now, you could use a little bit of algebraic sense here and go, look, if I have 1a on top and 1a on bottom, I can simply just cancel those a's out and just do 12 divided by 3, and I would be left with a value of 4. Question 3. So question 3 is very similar. Notice that you have 10 over 5. 10 over 5 is a whole value of 2. And if I have 1m on top and 1m on bottom, they cancel out. So guess what? My answer is 2. Jump down to number 5. Draw your fraction bar. So after you draw your fraction bar, start with your numbers. 4 over 8. 4 over 8 is 1/2. Now, you can use your rule here, x to the 5th over x to the 1st. So x to the 5th, when you're dividing, you're just subtracting the exponents. And so whatever answer I get here, that's going to go on the top part of the fraction bar. 5 minus 1, that would give me x to the 4th. So that's going to go on the top part. So here's another way of answering number 5. Start with the number 4 over 8 is 1/2. You have 5 x's on top and 1 x on bottom. If I were to write that out in expanded form, if I were to say 1, 2, 3, 4, 5 x's on top, and then did 1x on bottom, how many sets could I cancel out, if you want to call it sets? I could cancel out 1 set of x's there, and that would leave me with 4 on top and none on bottom, so I'd be left with 1 x times x times x times x. That is x to the 4th. And I just simply have the number 2 on the bottom. And there's your answer. You can actually simplify that by simply saying 1 times x to the 4th is x to the 4th, and put 2 on the bottom. All right, let's jump over here to number 6. We're going to skip around a little bit. Number 6, start with your number. Let's draw my fraction bar. 12 over 4 is a whole value of 3, so a whole value goes on the top part of the fraction bar. I don't have any x's to evaluate, so I'm going to leave x on the bottom. But notice my y's, y to the 3rd and y. So if I apply my rule, y to the 3rd, so I'm going to subtract the exponents, y 3 minus 1, that's going to be y to the second. And our answer goes on the top part of the fraction bar. Okay? Let's try another one here. Look at number 7. So we're getting into some negatives. And that's all right. Just remember your rules for negatives. Start with your number. Negative 6 divided by negative 15. I know that 6 does not go into 15 evenly. So if you need to, use your calculator. Do negative 6 divided by negative 15. And the calculator's, oh, it's going to give me 0.4. What is 0.4 as a fraction? Well, I can go math, frac, enter. It's going to give me 2 over 5. So it will automatically reduce for me. So I know 2 goes on top, 5 goes on bottom. It's positive because a negative divided by a negative is going to give me a positive value. Start with your letter P. P to the first and P to the first. Well, guess what? Those just simply cancel out. And then I have Q to the second over Q to the first. And if you have to write that out, Q to 2 minus 1, it just gives me the letter Q. And here's my answer. All right, jump down to number 9. You're going, oh gosh, now it's getting really crazy. Start by drawing your fraction bar. Look at the numbers. 32 over 20. So take your calculator. 32 divided by 20. It's going to give you some kind of decimal. 1.6. So then we're going to math, frac, enter. So it tells me that is the same as reducing it down to 8 over 5. Start with your A's. A to the second over A. So if you have to come over here and write that out, you're simply going to subtract the exponent. So that's 2 minus 1, which is going to give me a value of just 1A. B over B, that cancels out. If you have 3 C's on top and 1 C on bottom, that's the same as having 2 C's on top. Or if you have to use your rule, 3 minus 1 is going to give you a value of C to the second, and there's your answer. Jump down to number 12. Number 12 looks really crazy. You have all kinds of craziness going on here. So let's start with our fraction bar. Draw the fraction bar. So you have your x to the first here and x to the third. This is how you write that. Remember, it's the top exponential value of 1, and we're subtracting 1 minus 3. We're just simply subtracting the exponents. This is where you need your calculator here if you can't recognize that 1 minus 3 is actually going to give me a value of x to the negative 2. Remember, whatever answer we get here, you're going to put on the top part of the fraction bar. So I'm done with my x values. Look at your y values. If I have y to the second up top and y to the second on bottom, those two just cancel out. If you have the same amount of y's on top and bottom, they just go away. And then my last part here is z to the third over z to the first, so that's 3 minus 1. Well, 3 minus 1 is just going to give me z to the second. But we see something funky here, people. We do not like negative exponents. And remember our rule for negative exponents. You change the sign and cross the line. So that means that x to the negative second power, if I were to write a new fraction bar down, this whole guy, this x to the negative second, change the sign and cross the line. So it becomes positive 2. And of course we're going to leave z to the second up top. And there's your answer. Now another way to look at this problem, and I'm going to erase all this up here, is to look at what you have more of. As far as, are there more x's on the top up here, or are there more x's on the bottom? So since I have more x's on the bottom, obviously my x's are going to stay at the bottom. So that's kind of a little shortcut here. So since I have 1 x on top and 3 on the bottom, if I were to write that out in expanded form, 1x on top, and I wrote 3 of them on bottom, and I crossed out any matching pairs, guess how many I'm left with on the bottom? 2, right here. So if you don't like the exponential rule up here, and you want to write it out in expanded form, you can do that as well.